Hello and welcome, I'm your Code Monkey, and in this video we're going to create the ping system from Apex Legends. Let's begin. So Apex Legends has a bunch of really interesting systems, and in this video we're going to recreate the ping system. It's one of the best features of the game and one of the reasons why the game has been so successful. By using simple pings combined with context detection, the game can be fully played cooperatively without ever talking to your teammates. So for example, if I press the ping button on the middle of nowhere, you can see that I get a very nice, simple movement ping that stays visible even when it goes off screen. So I move away, and there you go, that is telling me that there's a ping in that direction and it shows the distance. However, if I press on top of an item, like say this helmet in here, I press it and there you go, the ping is correctly context sensitive and displays that there's a helmet in that direction. And again, if I move away, move the camera, and there you go, that's telling me there's an helmet in that direction. Works for all the other item types exactly as intended. And if I double click, instead of getting a simple movement like this, I double click and it shows a enemy spotted ping. So with just one button we can create 3 different ping types that provide a multitude of information for our teammates. And we also have a ping wheel that can be displayed when we hold on the ping button, and we have even more ping types to show. So for example, saying that an enemy was spotted in here. And again, if I move away, there you go, you can see that there's a ping indicator saying there's a ping 65 meters in that direction. Now this is a really cool system and certainly one of the reasons why the game has found so much success. Because again, even without a microphone, you can communicate quite effectively with your teammates. So we're going to implement this system in 2D, but it really works pretty much the same in 3D. Alright, so let's get to it. Here is my starting scene. I have a simple character in here aiming towards the mouse, and I can move him around and shoot. Now the ping system will be completely separate from anything else, so the base movement code and aiming here doesn't really matter. All we're going to focus on is to store the position of the ping and identify what's behind the mouse so we can display it. I have done videos on a simple character movement and camera system, so check those out to see how to create a basic character movement like this. So with this base, let's start making the pings. We want to click on the middle mouse button as our ping button, and when we do, highlight whatever is under the mouse. And if nothing is in there, we show a move ping, and if we double click, we show an enemy ping. So let's start off with a very simple prefab to show the ping position. So in here we create a new game object, and we add the sprite render component and drag the move ping sprite. Okay, so this is our simple game object. Now let's make this into a prefab. So first create a prefabs folder. And let's drag our ping into there to make it into a prefab. Okay. Let's rename this to pf ping world. This will be a prefab that will spawn whenever we want to display a ping in the world. Now let's create a class to handle our ping system. So in here, make a new C# script for our ping system. In here, let's first make it a simple static class. We're making it static since we only want to have one ping system and we do not want to instantiate it. Now let's have a function to add a ping. In order to add a ping, we're required to know the position for that ping, okay? And in here, let's just spawn our prefab. In order to get a reference for our prefab, let's add it as a new field on our game assets. I've done a video on how this class works, but essentially what it does is we can provide public fields and then we can access those fields to get our references from our other scripts. So in here, we can simply add a public transform field for the pf ping world. And now I can go here into the ping system and I can instantiate, go into the game assets.instance.ping world. And just like that, we have a reference to the ping world, which is stored as a public field in the game assets class. And here in the editor, I have a game object that contains that script, and I can simply drag the reference onto it. So now through code, I can access this reference. Okay, so now back in here on the ping system, we can now instantiate this prefab onto this position. So instantiate the prefab on the position we receive and quaternion.identity in order to not be rotated. Alright, so we should now be able to call this function and be able to see a ping exactly on that position. So now let's capture the mouse input. So for that, let's create a game handler. Just a simple script where we can capture our mouse input, and let's drag it onto this game object. And in here, let's go into our private void update and simply do a if input.getMouseButtonDown we want the middle mouse button. So button 0 is the left one, button 1 is the right, and button 2 is the middle mouse button. So when we press the middle mouse button, let's simply add a ping. So we go into the ping system and we call the add ping function. And now in here, we need to know the mouse wheel position. So for that, let's go into the CodeMonkey utilities, which as always you can grab for free from unitycodemonkey.com. And in the utilities, there's a very simple function to get the mouse wheel position. All right, so just like that, when we click on the middle mouse button, we should be able to see the ping prefab being spawned. Let's see. Okay, so here I am moving around. I put the mouse over here and I click the middle mouse button. And yep, there you go. There's the prefab showing that's a move position. And we should move in there. Put another one there and there you go. All right, great. So far so good. Now let's add a distance to the ping. For that, let's edit the prefab. And inside, let's make a new 3D object using TextMesh Pro. Okay. And we're going to use this to display the distance. Okay, so we now have a nice distance text. Now let's make a script that will run on that prefab. So in here, make a new C# script. This will be the ping distance handler. Let's drag that script onto the distance text. Okay. Now here on the script, first on the private void awake, let's grab a reference to the text mesh object. And then on the private void update, let's update to show the distance. Now in here we need to calculate the distance, so we need to do a vector3.distance. First we need the position of the ping, which is on the transform.parent.position, since this is running on the text object, which is a child of the ping prefab. And then we need the player position. So we get the ping position, then the player position is based on the class that is handling the player. You simply get the position from there. Then we calculate the vector3.distance between those two. And now in here, how you convert it into meters will depend on how you set up the units in your game. So this will return the number of units. Now let's convert it into meters, which in my case, given the size of the sprite, let's simply divide this by 3f. So around 3 units equals 1 meter. Then let's convert it into an int. So we do a mathf.round to int and round it all into an int. All right, so that should do it for displaying the distance from the ping to our player. So let's test again, and now we should be able to see the ping correctly display the distance. Okay, here I am with my character. Now let's put a ping in here. Yep, there you go, it's 37 meters away. Now if I move the player, yep, there you go, it is correctly updating, showing the distance from the player to the ping. All right, great. So now that we have the basics of our ping working, let's make sure that it's always visible. Since right now, if I move the camera to the left side, you don't actually know that there's a ping in there. So let's do that. We're going to make it always visible by adding a secondary ping indicator in the UI. So let's go into our canvas. In here, let's make a new game object. This will be our ping window. And inside, we're going to make a prefab very much like our normal prefab. Okay, that's pretty much it. Let's make it into a prefab, the same as we did with the ping on the world. So now we have a ping world prefab and a ping UI prefab. So now let's make the code for our ping window. So create a new C# script for the ping window. And here, let's first create a static instance so we can interact with this window through static functions. So we just make a private static ping window. This will be our instance, and we simply set it on our awake. All right. So now let's make a public static void add ping, and we'll receive a vector3 for the position of that ping. And in here, we're going to instantiate the UI prefab. Again, let's add a new field into our game assets class. So we have the pf ping UI on the game assets class, and we instantiate it onto this transform as the parent. So we have our instantiated ping UI transform. Now in here we need to reposition and either show or hide the prefab. So for that, let's make another script that will run on that prefab. New C# script, call it the ping UI handler. Let's drag it onto the prefab. Okay. And now in here we need a function to receive the target position for this particular ping. So let's make a public void, call it setup in order to set up this ping UI. And we're going to receive a vector3 for the ping position. Let's store it in a field. All right, now let's do an update. And in here, let's locate the anchored position. Now for the anchored position, let's place it in a circular area. So what we want is, let's say that the actual ping is over here outside the bounds. So we want this one to be shifted in a circular area around, pointing in that direction. Then let's say it's down here, we want to point it in there, and so on. So in order to figure out the radius that we should move in, let's look into the canvas. And here I have set it up to match with the height. So that means that when the aspect ratio changes, like for example 5:4, you can see that the height stays the same and only horizontally it changes. So that means we can use the height as the radius for our circle and it will always be visible. So in this case, in order to make it always visible, let's use 270 as our radius. So back in the code, let's first calculate the direction towards our target. And here we're going to use the distance from the camera rather than from the player, since we are supposed to be pointing towards something we cannot see, so the camera makes more sense. And let's calculate the direction, which will be the target position, which is the ping position, minus the from position. So now that we have the direction towards our target, let's place it in the UI using that direction and the UI radius. All right, that should do it. And just like that, we should have this object being pointed towards the ping position. So now we can go into the ping window. And in here, after we instantiate the ping UI transform, let's get the component for the ping UI handler. And we call the setup function and we give it the ping position. Okay, that's pretty much it. And lastly, here on the ping UI handler, let's update the distance just like we did in this script. All right, so that should do it. And this code is working exactly the same, except for the ping position. We're using the one we received on our setup. And finally, we call the add ping function on the ping window whenever we add a ping to the ping system. So in here we are adding a ping and we go into the ping window and we also call add ping and we pass in the same position. So let's see if the UI ping does follow in the same direction as the actual ping. Okay, so here I am. Now if I fire a ping, yep, there you go, there's the world ping and there's the UI ping. Now let's see if it's pointing towards it. And yep, indeed, it is pointing towards it based on the camera position. So I can circle around, and if that ping is now hidden, I know that there's a ping in that direction. So I move towards it, and yep, there it is. All right, great. So the UI ping is telling me both the direction and the distance towards the actual ping. Okay, so far so good. Now, obviously, we only want the UI ping to be visible when the actual ping is off camera. When it's visible, then we don't want the UI ping to be visible. So let's do that. Here in the ping UI handler code, we need to do a test to see if the ping position is inside the camera. So for that, we do a camera.main.world to screen point, which transforms a position from world space into screen space. So we can take the ping position. This will return a vector2 containing the ping screen coordinates. So now we can test if these screen coordinates are inside the actual screen. So in here we define a boolean, call it is off screen. And essentially we can test if it's off screen by testing the ping screen coordinates. Test if the x is bigger than screen.width, then it's off screen from the right side. Let's do an OR. So we have our boolean testing if it's off screen, and if it's off screen, if the screen coordinates are past the width, or under 0, or bigger than the height, or under 0. Alright, so using this boolean, we can easily set this game object to either visible or hidden. Now in here, the simplest way to make it visible or hidden would be to set the game object.setActive. However, in here we cannot do this, since if we were to set this setActive to false, then the update would never run and it would be hidden and never shown again. So instead of disabling the game object itself, let's disable the image and text components. So in here we only enable the image when the ping is off screen, and if it's on screen then we disable it. Same thing for the distance text. And here we only update the UI position and the distance text again when the ping is actually off screen. So when the ping is on screen, then the UI element is simply hidden and it doesn't do anything. Okay, so that should do it. Let's test. Okay, here's the character. Let's spawn a ping. And there you go, there's only the world ping. The UI ping is not visible. Now let's see if we move away. And yep, there's the UI ping showing that an actual ping is 90 meters in that direction. So we go towards it, and when it shows up on screen, there you go, the UI ping vanishes. And let's spawn another ping. And look at that, there's a ping in that distance, ping in that distance, and we go, and yep, when they're on screen, the UI pings vanish. Alright, so far so good. So we now have a ping in the world, and it's also shown in the UI if the world ping is hidden. So essentially we have all the code to function with the basic ping logic. So now we want to add different ping types. So here on the ping system, in order to have multiple ping types, we need to store the type and not just its position. So we need to rewrite this code in order to have the addPing function receive more information than just the position. So for that, let's use a custom class which will contain all the information needed for our ping. So we do a public class, let's call it a ping. And in here, the information we need in our ping is, first of all, we need a type. So let's define a public enum for the type of this ping. And for the valid types, we have the move, which is the one we were using, and let's also make an enemy type. Then we store a private type for the ping type and a private vector3 for the ping position. Alright, so here we have a nice, very simple class to handle a single ping. We have the type, and we have the position, and various functions to ask what type and position this ping has. So now let's change all of our addPing functions to receive a ping object. So we do ping, ping, instead of receiving just a position. So in here, instead of getting a position, we need to go into the ping and get the ping position. Okay. Now for the addPing, let's pass in our ping object. Now let's edit this. And here, same thing, we receive a ping object, which is inside the ping system. Alright, so all of our code has been reworked to work with this specific class, which contains our ping object. So now all that's left is here in the game handler when we add a ping. In here we need to pass in a ping object. So let's create a new ping system.ping. In here let's choose the ping type as a move ping, just as we were doing, and then pass in the world position. Alright, so we refactored the code to work with this new ping object, and everything should work perfectly fine. So let's test. And there's my character, there's the ping, still works perfectly fine. If I move away, the UI ping still works perfectly fine. Alright, so everything is still working, but we have successfully refactored our code to use a specific class to be able to handle all of our pings. So now let's start testing creating an enemy ping. So here on the game handler, let's test spawning an enemy ping on the right mouse button, so on the ping button 1. And we call it, instead of being a move type, let's say it's an enemy type. So if we click on the right mouse button, we should see an enemy ping. We will later make it work by double clicking, just like in the game, but for now let's keep things simple and make it this way. So with just like that, we are already creating a ping, which contains the enemy ping type. Now we need to swap the visual based on the ping type. So let's go to where we were creating the world ping, here on the ping system. And in here, after instantiating the transform, let's do a switch on the ping type. And now in here we could have different prefabs for each type of ping, but we can also use the very same one and then through code modify the visuals. So in here, after instantiating, let's do a switch on the ping.getPingType. Case we have pingType.move, that's default, so we don't do anything. Let's do it as the default, yep. And then we have case pingType.enemy, then this is where we need to change the visual. So let's change the sprite and the text color. For that, let's go into the game assets as we've been doing. So here, let's add fields for our sprites. So we add a sprite for the ping enemy sprite. Then let's also add a reference to the colors. All right, these are all the assets we need. So now we can go back to the ping system. And here we take the ping transform, we get the component for the sprite render, and we change the sprite to the game assets, and we pick the enemy sprite. Then let's also change the color of the distance. Alright, so just like that, in here if we receive a ping that contains the enemy ping type, we change the sprite render sprite and we change the distance text mesh color. So now let's fill up these values on the editor. Here's the game asset script, let's fill that in. Okay, so we have added the reference to our sprites and our colors, so let's test and see. Okay, here we are, let's spawn a ping, a move ping first. And yep, there's the move ping, exactly the same as previously. Okay, great. Now let's spawn an enemy ping. And yep, there it is, the enemy ping with the enemy color being applied both to the text and to the sprite. And there you go, there's another one. All right, great. So far, so good. Now let's make sure we deal with the UI sprites as well. We can deal with them here on the ping UI handler, which is a script that is being run on each UI element. So in here we do a switch on the ping, get ping type, and so on. All right, that should do it. Let's see. So here's a move ping and an attack ping. Now if I move away, and yep, there you go. There's both pings correctly showing the correct color and the correct sprite. All right, great. So now that we have this working, let's make it work just like the game by double clicking the mouse button. So for that, let's go here into the ping system class. And here what we need to know is if we get two move pings, one right after the other. So first, let's make a simplified version of the add ping function, one that does not require a ping object, but rather just the position. So this simplified version is what we're going to call on the game handler. So instead of sending in a ping object with its type, we just send in the ping position. And let's remove this second one. Okay, that's it. So now all the logic is handled in here. And now this function will decide the type. So in order to test if we got two move pings in a row, we need to know what was the previous ping. So let's store the last ping. When we create a new ping, let's set the last ping to the newly created ping. Okay. And in this function, let's test if the last ping, if it is not null, and the last ping.getPingType equals a move ping. So in here we know that last ping was a move ping. So now we know that two pings were added and the previous one was a move ping. Now let's test for the time difference between them. So let's also store a private static float for the last ping time. And we're going to set it when we set the last ping. Alright, so we know what the last ping was and when it was created. Now all we need to do is define some sort of threshold for a double click. So let's put it up here as a constant. And let's say in 50 milliseconds. So if you hit the ping button twice within 50 milliseconds, then we want to create a enemy ping. So in here, if we're testing if the last one was a move ping, let's test for the time difference. So we test if the current time is under the last ping time plus the double click time. So if the current time is within 50 milliseconds of the last ping time, then we have our pings in quick succession, so let's create an enemy ping. Alright, so that's pretty much it. Now in here, if it was not in quick succession, then we add a normal move ping. And if we don't have a last ping, or the last one wasn't a move ping, then we simply add a move ping, the same as normal. Alright, so let's test and see if we can spawn enemy pings whenever we double click. Okay, so here I am. Now I press once, and yep, there's the normal move ping. Now I press twice, and yep, there you go. The second one was a enemy ping. Alright, so the double click logic is working exactly as intended, but right now we also have to remove the old move ping. That one should be destroyed when the enemy ping is spawned. So here in the code I also made it 500 milliseconds because 50 was just way too fast. So let's go down here to make a function to destroy a ping. So you receive a ping object and we want to destroy it. So let's add a function on the ping to destroy itself. For the ping to destroy itself, let's simply add a boolean to check if it is destroyed. And a function to test if it is destroyed. And now in here, let's create an event that will be triggered when this ping is destroyed. Alright, so that's it. Now we have this event being called when the ping is destroyed. And here when we destroy the ping, let's call ping.destroySelf. And now using this event, we can destroy the actual visuals. So here when we instantiate the ping transform using this ping object, let's subscribe to the ping.onDestroyed event. And here when the ping is destroyed, let's just do object.destroy our ping transform. Alright, so just like that, we should be destroying the ping transform whenever the actual ping object gets destroyed. Now let's also destroy the UI ping. Here we are on the setup. Let's add exactly the same code, except we're going to destroy this game object. Alright, so that should do it. So now we have this destroy ping function, which should be working perfectly fine. So now we can go in here, and when we want to add a new enemy ping, we want to destroy the previous one, so we simply call destroy ping on the last ping. So we destroy the last ping, and then we instantiate a new enemy ping. Alright, so let's see if we can now instantiate a new enemy ping and the move ping gets destroyed. So here we are, ping once, and yep, there's the move ping, same as normal. Now ping twice. And there you go, you saw that the move ping appeared, but it vanished when we spawned the enemy ping. And if we move on the UI, they still work, and the others, everything still works. So spawn a new enemy ping in there, and there you go, spawn a new move ping, now an enemy ping, and yep, everything is working perfectly fine. Alright, so now that we have all of this working, let's add a timer for the pings to destroy themselves so they don't stay on forever. So let's go into the ping class. And in here, let's store a destroy time. This will be the time that we should destroy this ping. Let's define it in the constructor. So we set the destroy time based on time.time plus then some amount. So let's say after 10 seconds, each ping should be destroyed. Alright, so now we need to periodically test if it's time for this ping to be destroyed. So let's go into our ping system, and here we need a function that will be called on our update. Now this is a static class that does not inherit mono behavior, so we need to manually trigger this function from somewhere else. So let's go into the game handler, and here we have our update, and we can simply go into the ping system and call the update function. Alright, so we now have this function being triggered on every update. So in here we need to cycle through all the pings, so we need to store a list of all of our pings. And on the update we need to cycle through that list. And we test if time.time is bigger than the ping.getDestroyTime, then it's time to destroy this ping. So we call destroy ping of this ping, and since the ping destroy ping will remove it from the list, let's go here, remove our ping. Since we are modifying the list in here, we need to go backwards on our iterator. Alright, so that should be working. Now let's add pings to our list. So in here we got the add ping. When we add a new ping, let's do ping list.add our ping. Okay. And the final thing we need is to actually initialize this list. So let's make an initialize function. And in here, we just initialize our ping list, and we need to call this somewhere. So let's go into the game handler and make a private void await. All right, so here on awake, we call initialize, which initializes our list. Every time we add a ping, we add that ping to that list. On update, we get this function called, and we test if it's time to destroy each ping. And if it is, then we destroy it and we keep going. So let's test and see if the pings automatically vanish after 10 seconds. Okay, here I am. Let's spawn a ping and now a attack ping. And now let's see, after 10 seconds, this one should vanish. And let's wait. And yep, there you go. The ping vanished and the other one vanished afterwards. All right, great. And if we move away, you can see that the UI ping is indeed vanished. So we now have our pings with a very nice maximum destroy time. Now the next thing we need to work on are context sensitive pings. Essentially, we need to do a different ping based on what we click on. So for that, let's first create a simple item. So here, let's create an empty game object. Let's give it a sprite renderer component and pass in this medkit sprite. Now let's also add a box collider 2D so we can test. And that's pretty much it. Now when we click, we're going to do a raycast and see what we hit. So let's go into the ping system. And here when we have an add ping, let's test if we're clicking right on top of something. So we do a raycast. We do a raycast on the mouse world position. And for the direction, let's put vector 2.0. All right, so we got a raycast being done exactly on the mouse position. Then we test if our raycast hit, if contains a collider, then that means that we hit something. So in here we know we clicked on something. Now we need to identify what that something is. So let's go into the editor and we're going to create a script to identify that particular object. So let's create a new C# script and we're going to call this the item identifier. And in here, let's make a public enum for the item type. Let's start off with a medkit, also a helmet and some armor. Now let's make a field to store that enum. Okay, so with this symbol class, we can now go into the editor, select our game object and add our item identifier component. Now in here, select this one as the medkit. Okay, so now we can go back onto our ping system. And here when we are doing our raycast, we see if we do have a collider. And if so, let's try to grab the item identifier component. So we do our raycast hit. So in here we go into the collider, we get the component for the item identifier. If we do have that component, then that means that we've clicked on an item. So in here we have identified the type of ping that we want to create. So we add a new ping and now we need to add it as an item type. So here in the pings we have move, enemy, then let's say also item. However, the item can be different. So we need to go down here and also store what type of item this is. So we're going to store this, but only in the case that we have our type as the item type. An enum by itself cannot be null, but by adding our question mark, we are turning it into a knowable, and now the default value will indeed be null. So when we create a new ping, let's also receive an optional value for the knowable item type. So now let's go up here onto our add ping function. We're going to add it as an item. And then we're going to pass in the item type that we get from the item identifier dot item type. And just like that, we should be able to create a item ping based on whatever item is stored in the item identifier, which again is placed on the game object. So now that we can instantiate a new ping type with the item type, let's deal with changing the visual in here. In here we need to set the sprite and the color, so let's ask the item identifier for it. So here let's make those functions. Let's make a public static to return a sprite, and let's call it the get item sprite. And we're going to receive a item type. And we're going to have the same thing, a public static caller to get the item color. Alright, so we have these two nice functions which receive our item type, does a simple switch, and returns the correct sprite or color. So now here in the ping system, that's all we need to do. We need to go into the item identifier in order to get the item sprite, and we pass in the ping.getItemType, which you need to make a function. Alright, now let's do the exact same thing on our UI element. And that's pretty much it. So let's see. Okay, so here I am. There's the medkit. Now let's try a normal ping, and there you go, still works. And attack ping, there it is. And now I click the ping button on top of the item. And yep, there you go, there's the item ping showing that there's a medkit in there. Now if I move away from the screen, yep, there you go, the indicator correctly shows correct color and everything. Alright, so it's working perfectly fine. Now let's test out the other items. To add the other items, all we need to do is duplicate our item, so here it is. And all we need to change is here the item type on the item identifier. So change this one to the helmet, change it for the helmet image, do the same thing for the armor. And that's all we need to do in order to show our different items. So let's see the pings at work. So here it is, let's put a ping on the medkit, and yep, there's the medkit ping, and on the helmet, a helmet ping, and now an armor ping. As you can see, the color of the text and the various sprites, and they're all correctly showing exactly where each item is located. Alright, so everything is working exactly as intended. Our ping system is context sensitive, which makes it more comprehensive and easy to use. So far, pretty much all of these different types of pings only use the exact same ping button, and just depends on how fast I click and where I click on. So now finally, let's make the wheel menu to display even more ping types. So let's first create the ping wheel in the editor. Alright, so this is the visual for our ping wheel. Now let's deal with the code. Let's make a private void awake, and in here grab the references to the buttons and set their actions. And now in order to add a ping, we also need a position. So let's store it as a field that we will receive later. Alright, so now we need functions to show and hide this wheel. Alright, so we got some various static functions that we can call from elsewhere. So now we need to figure out how we're going to show the ping wheel. So the last thing we need is to receive a vector3 for the ping position, which is what we're going to store. Alright, so all of this should be working just for the move button. So now let's see where we're going to call this. So let's go into the ping system, and in here let's add two functions. So we have a function that will be called on every frame that the button is held down, and one that is called when the button is released. So let's capture those inputs. So here on the game handle, let's do a if input.getMouseButton. Just this one, which is fired on every update that the button is held down. So it asks for the button number 2, which is our ping button. If it is held down, then we call ping system ping button held down update. And then on the get mouse button up of again the second button, we do our ping system dot ping button released. Okay. So the input logic should be working. Now let's go back in here. And now we need to count the number of times that we are holding down the ping button. So let's make a field to hold that. Now on this function, we're going to increase it by time.delta-time. And now we're going to check if the hold down timer is bigger than a certain threshold. So let's define it up here. So if we hold the button down for 1 second, let's go down here. If the timer is bigger than the constant timer, then we want to show the wheel. So we test if the pinwheel, we test if is visible. So we want if it's not visible, and if not visible, we do pinwheel.show, and now we pass in the ping position, which again we go into the utils class to get the mouse wheel position. And finally, when we release the button, we simply set the ping button hold down timer to 0. Alright, so that's pretty much it. So here on the game handler, we are capturing for our inputs. Whilst we're holding down the ping button, we are increasing a timer. If the timer goes past a certain amount, then we show our pinwheel. And on the pinwheel, we show the game object, and we have some buttons to add specific pings. Right now only the move one works, but let's test if that one is working. Okay, so here we are. Let's do a normal ping, still works. Enemy ping, still works. Item ping, still works. Now I hold down the ping button, and yep, there it is. After 1 second of holding down, I can see the ping wheel, and now I select whatever ping. Only this one is working, so let's click on it, and there you go, it showed up in there. Now we need to destroy the previous one, so let's deal with that. On the ping system, let's create a function to destroy the last ping. And now we can go into the ping wheel, and when we show it, we call the ping system and destroy the last ping. That way that move ping should vanish when we create this one. So let's see. Okay, click here, show the ping window, and that ping vanished. Now I select this one, and there you go, it spawned that ping in there. All right, great. Now let's apply the exact same thing to all other ping types. Alright, the code in here should be working. We simply set a different ping type for each button. Alright, everything is set. Let's see. Okay, so here we are. Normal move ping, enemy ping. Now show up the ping wheel. Now select this one. And yep, there you go. There's that special icon. Now select another one, select this one. And yep, there it is. So there it is. All of the various ping types are working perfectly fine. And if we move to the corner, everything works exactly as intended. So there you have it. We created the ping system from Apex Legends. We can click somewhere random and just fire a normal move ping. We can double click, which creates an enemy ping. We can ping on top of an item, and it automatically identifies the item under the mouse and spawns that specific ping. And we also have a ping wheel that shows up if we hold the button down, which gives us even more ping types. All ping types also have an indicator in the UI in case the ping is outside of the camera view. As always, you can download the project files and utilities from unitycodemonkey.com. If you have any questions, post them in the comments and I'll do my best to answer them. Subscribe for more videos, and I'll see you next time.